Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Okay, level 29, by integration, determine the moments of inertia about the x and y axis for the region shown. So here's the given figure, and for this problem, for our solution, let's select vertical strip as shown in the figure, then extend it so that our base, the differential, would be differential x, the variable of integration is x, so limits would be from 0 to 1. And we have an upper y and lower y. So this is the upper y defined by y equals x, the lower y is defined by y equals x squared. And the distance of the strip from the y-axis is x. So the differential moment of inertia with respect to the x-axis is, you have to imagine that it is moment of inertia of a big rectangular strip of height upper y minus the moment of inertia with respect to the base of a smaller uh, rectangular strip of height lower y. So therefore, differential Ix is 1/3 quantity upper y cube minus lower y cube times dx. So this point is at 0, is at 1 comma 1, because when x is 1, here y equals x, then y is 1. Also in y equals x squared, when x is 1, 1 squared is still 1. So differential Ix is 1/3 quantity upper y cube minus lower y cube differential x. So substitute upper y cube is x, so Ix is 1/3 integral of from 0 to 1 of quantity x cubed minus x squared quantity cube dx. So take note that the second term is x to the 6. So Ix is 1/3. The integral of the first term is quantity x to the 4th over 4. The second term minus x to the 7 over 7 from 0 to 1. Since upper limit is 1, so this is just 1/4 minus 1 over 7, then lower limit, don't mind, 0. So 1/4 minus 1 over 7 times 1/3, so Ix is equal to uh, 1 over 28 meter to the 4th. So likewise, differential Iy is x squared times differential area, and the differential area, the area of the shaded orange strip, is quantity upper y minus lower y times thickness dx. So differential Iy is x squared, distance squared, differential area upper y minus lower y times differential x. So again, upper y is just x, lower y is x squared. So differential Iy is x squared quantity x minus x squared dx. Iy therefore is integral 0 to 1 of x cubed minus x to the 4th dx. And Iy is quantity x to the 4th over 4 minus x to the 5 over 5 from 0 to 1. So Iy is quantity 1/4 minus 1/5 minus 0. So Iy is 1 over 20 meter to the 4th. Level 30, without integration, determine the moments of inertia about the x and y axis for the region shown. This is actually problem 29, and we solve this again without integration. And let's use the derived formulas for this curve here in general from level 4. So for our solution, we use Ix equals, if you can recall, bh cubed over 3 quantity 3n plus 1, and Iy is b cubed h over 3 plus n. So Ix is bh cubed over 3 quantity 3n plus 1, and Iy is b cubed h over 3 plus n, where both b and h here are equal to 1 because this is 1 comma 1, and for Ix it is moment of inertia of a triangle first degree, so n is 1, minus moment of inertia with respect to the x-axis of this under this curve of degree 2. So substitute here. So that's 1 comma 1. So Ix is 1 times 1 cube over 3, quantity 3 times 1 plus 1. Then minus moment of inertia under this curve using the same formula where n is 2. So minus 1 times 1 cube over 3, quantity 3 times 2 plus 1. So the first term is 112, and the second term is 3 times 6 plus 1, 7 times 8, 1 over 21. So 1 over 12 minus 1 over 21, and that is equal to the answer in the preceding problem, level 29, 1 over 28 meter to the fourth, using your calculator. So for Iy, it is b cubed h over 3 plus 1. So moment of inertia of the region under the first degree curve y equals x, then minus moment of inertia under the region of n equals 2. This is our guide formula. Iy equals 1 cubed times 1 over 3 plus 1 minus 1 cube 1 over 3 plus 2, second degree. So this is 1/4 minus 1/5, and 1/4 minus 1/5 is 1 over 20 meter to the fourth. So that's it. I hope that you can follow and you remember this formula, although you can evaluate the moment of inertia with respect to x and the y-axis with confidence and convenience by integration, just like in level 29. Level 31, by direct integration, determine the moments of inertia about the x and y-axis for the region shown. So here's the given figure. So for our solution, let's select again a vertical strip so that the height of the strip is y, the thickness is dx, and the distance of the strip from the y-axis is x. So differential Ix is equal to moment of inertia of rectangular strip with respect to the base, and that is 1/3 y cubed dx, where y is equal to this. So Ix equals 1/3 integral from 0 to a of k e to the x over a quantity cube dx. So since at this point x is a, y is b, substitute into this formula to evaluate k. From y equals k e to the x over a, b is equal to k e to the a over a, and a over a is 1, so this is just e. K therefore is b over e. Then substitute here, k cube, so ix is k cube over 3, integral 0 to a of e to the 3x, e to the x over a quantity cube is e to the 3x over a dx. So if you let u be 3x over a, the differential is 3 over a dx, and the reciprocal is a over 3. So therefore, ix is k cube over 3 times quantity a over 3, integral from 0 to a of e to the 3x over a quantity 3 over a dx. So this is in the form for this part, integrand e to the u du, and the integral of e to the u du is just e to the u. So Ix is a k cube over 9 quantity e to the 3x over a from 0 to a. So e to the 3a over a is a cube, minus e to the 0 is 1. So Ix is a k cube, and k is b over a quantity cube over 9, e to cube minus 1. E to the 0 is 1. So from here, we can have Ix, which is ab cube over 9 e cube quantity a cube minus 1, and that is approximately equal to 0.1056 ab cube. For our differential Iy, it is x squared times differential area y dx. So differential Iy is distance square, x squared times y dx, or differential area. So substitute the value of y. So differential Iy is x squared times y, which is equal to k, which is b over e to the x over a dx. So Iy is b over e integral 0 to a of x squared e to the x over a dx. So this is product of algebraic function and exponential function, and we can evaluate this by integration by parts. So let u be x squared and differential of u is 2x dx. Likewise, dv is e to the x over a dx, and the integral is a e to the x over a. That's the integral. So dv is e to the x over a dx. So reciprocal of 1 over a is a. So the integral is a e to the x over a. That's the integral. So it is equal to uv. Iy is b over e times quantity uv minus integral of v du. So e over b iy equals this integral here, and it is uv x squared a e to the x over a from 0 to a minus integral of v du. So this is v, a e to the x over a, du is 2x dx. So e over b iy equals a cubed a squared times a. So a cubed times a e to the a over a, so e to the 1, or simply e. Then lower limit is just 0, so a cubed e minus, so this is 2a integral of e to the x over a, 2a integral of x e to the x over a dx. So for this integrand here, we let u1 be x, and the differential v1 is e to the x over a. So differential u1 is dx, differential v sub 1 is e to the x over a dx, and the integral is v sub 1, and v sub 1 is a e to the x over a by our experience here. So we expand this part, and it is equal to u1 v1 minus integral of v1 differential u1. So e over b iy equals quantity a cubed e minus 2a quantity x a e to the x over a from 0 to a minus integral of a e to the x over a times dx du1. If we substitute limits here, this is a, so a squared e to the 1, a over a is 1. So this is just a squared e to the 1 minus lower limit 0. So e over b iy equals quantity a cubed e minus 2a cubed, or 2a quantity a squared e minus the integral of e to the x over a dx is a e to the x over a, again from 0 to a. So simplifying, e over b iy equals quantity negative a cubed e, because a cubed e minus 2a cubed e is negative a cubed e. Then negative 2a, negative a is plus 2a, 2a is cubed. Then e to the a over a is e, minus e to the 0 is 1. So e over b iy equals a cubed e minus 2a cubed. Factor out a cubed. So e over b equals iy equals a cubed quantity e minus 2. Finally, iy is a cubed b over e quantity e minus 2, and that is approximately 0.2642 a cubed b. So that's it for this level 31 problem, though it defeats the purpose for computing moment of inertia of common sections, but this is a good practice in reviewing your integral calculus or calculus in general, and for you to master moment of inertia without memorizing formulas by simply setting up the integral. Though the more practical sections should be the ones that are common. So, but this is a good uh, problem, good ground where you can recall and you will be forced to recall integral calculus.